Ever since I did the video with my grandson where we would pump up soda bottles to 100 psi and then shoot them with a pellet rifle to watch them blow up, I've been thinking about how could I make a motor that would run off of air, and maybe even a cart that was made out of the soda bottles that would power that motor. That's what this video is about. Stick around. Here's a view of the completed 3D model. It's basically a little 3-cylinder engine. Each of the cylinders 1.5-inch bore with a 2-inch stroke. The cylinders are operating 120 degrees out of sync with the other two, so that one will always be in what I'm calling the power stroke. Here's a simplified view where I show only one of the cylinders and the piston and rod and only one of the timing valves. Basically, the compressed air would enter the green elbow here, and it exits out the red elbow and up to the top of the cylinder where it enters the cylinder. This timing valve regulates when that all happens. So as the piston is coming down in this scenario here, the port with the green elbow aligns with the port of the red elbow, forcing compressed air down into the cylinder, causing it to come down. Once it reaches the bottom end of its stroke and starts back upward, the air has to exit the cylinder. So now then the red elbow aligns with an open port on the sliding valve, and it allows the air to exit. So basically you have air coming in, air coming in, air going out, air going out. Here's the crankshaft I printed. I had to print it in segments because I have to be able to put these bearings on in certain locations. So I'll have to do some sanding on them. I've already done some sanding on this one, and I've already done some sanding on this one. So in this case, this bearing is going to go right here, like so. That's part number one. Then part number two, I also have to have a bearing on. It's going to go right here. You want them a little bit snug, like that. So this will go to here. I have these indexing nubs, you might call it, where each one of these pieces are indexed to the piece that it adjoins to. And what I'll do is once I get all this together and fit it into what I'm calling the block to make sure everything's all aligned, then I'll put super glue on there. Another thing I have to be aware of is that because these parts are printed, I know that the distance might not be exactly, or they might not be exactly the right thickness. So I've created this sheet here that shows me, for example, between this part 1 and part 2, I should be at 0.6 inches. So I take the micrometer here and I take and measure that distance just to make sure they're going pretty close together. I'm at 0.615. So this is a little bit thick. I'll have to do some work on this to get it to where it goes together a little bit better. Part number 3 adjoins to number 2. I can tell by my colored image here that part number 3 will adjoin to part number 2 because it's turned like this. And now then this part here is going to be, it's actually turned like this. This part here will be facing down like so. But I have to put a bearing on there first. So let's slip a bearing on, like that. And then this will go like this. And again, I have to check the thickness here. I can tell right off the bat that this is thicker because I've got slack in here. So what it's doing is this nub, this indexing nub, is a little bit too long, so I need to take some of that off. Since it's very difficult to work with these pieces, they're flopping around, they're just kind of hard to deal with, and you got to make sure you get them in exactly the right order, particularly before you glue them. I've decided to go ahead and assemble what I'm calling the block, or at least part of the block. Here's what the crank shaft is going to set in. So I need to go ahead and put these things in the base here so that I can set the crankshaft in here as I'm assembling it. So I'm gonna have me a nice flat surface here. I take these, and these are gonna set in like this. And the main thing is I just wanna make sure that they're flush on the back, which that one is. It appears to be pretty lined up, so I'm just gonna put a little bit of super glue on it now. I don't see any bleeding through, so that'll be all right there. Let's go ahead and put another one in. Okay, this is part 1, 2, and 3 right here, and we're going to have 4 on there like so. And I believe that this is going to go in here right like so, like that. So you can see what it's looking like. Okay, so these parts are ready. My bearing caps here, so we're going to go ahead and put these on just to help hold this thing down as I build it. First I have to drill these holes out a little bit. The printed holes in these parts here turned out to be almost perfect for threading these screws into without any kind of tapping or anything. I'm just going to go real slow because I don't want to split those parts. I think that looks pretty good. Hopefully I have it assembled correctly, because if I don't, it's going to be a real pain to fix. So that about does it for the crankshaft assembly. We'll carry on to something else. Here are the components of one of the cylinders. This black part right here is a seal that I purchased off of McMaster car. It's supposed to work in an 1.5-inch diameter cylinder, but in my little plastic cylinders, which are 1.5 inches, this thing was really pretty large. So I've had to take and put it in a drill, turn it down to where it fits in the cylinder now. So now it goes like this. It's a nice, good fit there. Then I have the piston top that I printed, 4 of those, and here's one of them mounted to one of the crankshafts that I made. This crankshaft is glued into there, and then the screw that holds the rubber seal on goes through a printed washer, through the seal and into the piston and rod. So that holds that all together. And then this, of course, fits within the cylinder like this. One thing I'm concerned about a little bit is the friction and how much heat it's going to generate. I'm hoping this thing will run very slowly and not generate that much friction. I'm having a little bit of trouble finding the best lubricant to put in there. One thing I haven't tried, and I think I'm going to try, is graphite. So we'll get to that in a little bit later. But I did want to show you how I assemble this thing. So then I take the cylinder. I bought this O-ring material off of McMaster car as well. So what I do is I take a piece of it and I stuff down into my little groove that I created here. And then when I get over here, I'm going to take and cut it just a little bit long. Just a little bit. So then I pull it back out a little bit, get the seal started against itself, and stuff this back down in the groove. I take the cylinder head, put it on here, and these are 1024 screws. Unfortunately, these are not the nuts I wanted, but it's all I had. I made pockets for the proper size nut. These are a little smaller on the OD. So we're going to put those in place. These cylinders actually turned out pretty well. I sand them internally. Of course, they got the lines from the print in there. So I sand them with regular sandpaper, get them down pretty smooth, and I also take them and water sand them. They're not perfectly smooth, but I think they're going to be smooth enough. Okay, so then I tighten up these screws here. Okay, I don't want to tighten it down all the way. I think that's tight enough. I may have to go back and tighten them some more later, but for right now, I'm going to think that's probably good enough. Except this one is turning on me. There we go. Now then, the bearing for the shaft, there'll be a shaft that'll go through all three cylinders, and this is the way the bearing will fit in. Fits into the top like that. Again, the shaft will go through there, then there'll be a cap that goes on that bearing. But on this port right here, this is where the air goes in. I'm using these little nylon, I guess they are elbows, but I do have to do some work to them to get them to work. The first thing I have to do, and you probably can't see it, is there's 3 little ribs around the perimeter of the thing, so I have to shave those ribs off. Okay, then have to cut off this nub on the end of it. So what I do is I just roll this around. There we go. So then this fits into this port here. And of course I'm going to glue them in when it's all done, but anyway, it winds up like that. So you can kind of tell that I have some really good seal there. So anyway, that's how the cylinders are done. Finally, after a lot of trial and error, mostly with the part I'm calling the slide valve, I think I'm finally ready to assemble this thing. Here's an overview of the parts. We have the 3 cylinders, the pistons, the rods, the 3 bearings, and the rod that the cylinders pivot on. We have the supports that support the rod that the cylinders pivot on. We have the block that I have mostly assembled. I still have some to do to that. And then we have the 3 timing valves. These are the ones that's given me the most problems trying to figure out how to make this work. I'll get these temporarily placed, and then I'll come back and glue them a little bit better. Again, I just want to make sure that they're flush on the bottom, which that is. The ones on the outside have the single hole in them because there's a mounting bracket goes there. The ones in the middle have this bushing built into them here because the shaft goes through there. Okay, so now then for the cylinders. I finally determined that the best lubrication I could use was actually no lubrication at all. I went back and sanded these down a little bit because they were still a little bit tight, and I think I have them working pretty well now. We'll go ahead and mount this piston to the crankshaft, and we'll see how well this works. So maybe you can see that. When you got 9.5 fingers, it's not quite as good as having 10. Now the bearings I've used on this thing, I know are probably not the most ideal bearings, but it's what I had readily available and that I could easily get. Okay, there's the 3 pistons in place. Now we'll install the cylinders. I think I've already glued all of these in. Yep. So first thing we'll do is go with this one. Okay, now we need to get this rod through here that supports all those. Okay, now we have these caps that I made that holds that in place. It's got to put a little screw in there. Seems like it's going to work. I now have all 3 of the slide valves, or timing valves you might also call them, sanded. I have the elbows glued in place. I have the faucet seals in place with the springs behind them. So now that I need to assemble these, this just slides together like this. And I have to depress that seal a little bit to get it in there. Just pushing it down to get it started. Now then it's in there, so now I have the first slide valve ready to go. Let's go ahead and do these others real quick. All right, now then we're ready to put them into the assembly here. So it's got to go around this bearing here. So it goes around, and then I have these caps made to go on there and capture them. Now we have to slide this rod through them. Maybe you can see what I'm doing here. And that's what's supposed to regulate when the air enters the cylinders. So next we got to hook the hoses up. All right, this is the hose that I've got. It's not exactly what I wanted. It's a little bit stiff. I think it might work, but it's not what I wanted. I also needed some T's, and the hardware store didn't have any. I didn't have time to get them ordered, so basically I downloaded the 3D files and printed a couple of them. Then I covered them with super glue to help seal them. I don't really know how well they'll work, but we'll find out. Well, here it is all plumbed up. Again, I think the tubing was a little too stiff for me. And I admit I did put some air on it already. I started off about 40 PSI. I still have leakage in my slide valves. That's been my problem all along, is figuring out how to design something that I can print and still work. I don't have a metal lathe or any kind of real metal working tools, so you know, I'm doing the best I can. But let me show you what happens here. If I put some air on it, well, actually, that's the best it ran. That's at 60 PSI of air. It's not bad. Let's do it again. Sounds kind of cool. Okay, there it is. There's my 3-cylinder, 1-stroke air-powered motor. It's not quite what I was expecting. I was hoping it would run on a little less air pressure. I'm at about 60 PSI right now, but it is printed parts. You know, it's I don't have any kind of metalworking tools, so it's about the best I could do. If you saw anything that you liked in this video, or if it was entertaining to you in some way, I really would appreciate it if you would subscribe and hit that like button. I'm new to YouTube and I'm trying to build my channel, and every little subscription helps. Thanks again for watching.